Hello everyone, I am Pavithra Devi, working as Assistant Professor in Department of Computer Science, Artificial Intelligence and Data Science in Dr. SNS College of Arts and Science. Now I am going to take the class about clustering with the K-means. Introduction to the K-means clustering. K-means clustering is the type of unsupervised machine learning algorithm used for the clustering data into groups or cluster based on their similarities. The goal is partitioning data into k distinct non-overlapping groups where the data points within the each group are similar to each other or different from those in the groups. Next one, basic idea of k-means. The algorithm divides the data into k cluster, each represented by the centroid, that is mean, of the points in the cluster. The centroid is the average of all the data points assigned to the cluster. K-means aim to minimize the intra-cluster variance or the sum of squared distance between data points and their respective centroids. Next one, K-means algorithm steps. First one, initialization. Choose the K initial centroid randomly or use K-means plus plus to spread out of the matter. Clustering assignment. Assign each data point to the nearest centroid based of the distance, usually elixir distance. Centroid update. Recalculate the centroid of each cluster by computing the mean of all the data points assigned to that cluster. Next one, repeat. Repeat step 2 and 3 until coverage when the centroid no longer change significantly or maximum number of different iteration is reached. Next one, how k-means works. Distance metric. Typically, k-means use the elixir distance to measure the distance between a point and the centroid. Coverage. The algorithm stops when centroid no longer change minimally between the iteration or the predefined maximum number of iteration is reached. Next one, K means algorithm, that is pseudocode. Now we are using the Python code. First initialize the K centroid randomly. Step 2, repeat until convergence. Assign each data point to the nearest centroid. Recalculate the centroid by averaging the data points in each clusters. Output of the final centroid and cluster assignments. Next one, selecting the number of clusters K, that is called as K. One of the most crucial aspect of the K means is selecting the optimal number of cluster, that is called as K. Common method for selecting K include first one, elbow method. Elbow method plot within the cluster sum of squares, that is called WCSS for the different values of K. Look for an elbow where the rate of decrease slow down. The point at which the elbow occurs is good choice for the K. Next one, silo score. Measure how similar each data point is to one cluster versus other clusters. The score range from -1 poor clustering to +1 well separate clusters. A score near 0 indicate overlapping clusters. Next one, gap statistic. Compare the performance of k-means clustering with the random reference distribution of the data. If the clustering is significantly better than random, k is considered as a optimal. Next one, key advantages of k-means. First one, efficiency. K-means is the computationally efficient and scalable for large dataset, especially when the number of clusters K is relatively very small. Next one, simplicity. The algorithm is straightforward to implement and understand. That is called as straightforward the simplicity algorithm. Next one, well suited for the large dataset. Works well on dataset where cluster are spherical or astropic for the smaller size. Next one, limitation of k-means. Choice of k. Determining the optimal k can be difficult and often based on the trial and error external validation metrics. Sensitivity initialization. K-means can coverage to different solutions depending on the initial random selection of centroid. This can result in suboptimal clustering. K-means plus plus is improved initialization method that helps to avoid poor convergence. Assume spherical cluster. K means assume the cluster are roughly spherical and equally sized, which may not hold in many real world data sets. Next one, variants and improvements of K means. K means plus plus, mini batch K means, K methods PAM, that is Gaussian mixture model. Next one, applications of k-means. There are lot of applications: customer segmentation, image comparison, anomaly detection, market basket analysis. Thank you.